Here we're given an equation here that has multiple unknowns in it. We have x, a, b, and c. We're told that b is not equal to negative c, and essentially we're asked here to solve for the one variable x. So if we think about how to solve an equation like this, first of all, I notice that there is a fraction in the equation. I know that this c down here can't be 0 because it's the denominator of the fraction. So I could multiply this entire equation through by c, both sides, without changing the solution. So I'm going to do that because then I will not have a fraction in my equation. Alright, so multiply both sides by c. On the left, we simply distribute and we get c times x. Plus, when we distribute the c times this fraction, the c's cancel each other out and we're just left with b times x, and that's equal to c times a. So again, here we're trying to solve for x, and so what I really want to get is a single x here times some quantity so that I can divide, hopefully, and give me x by itself. So the way that I can get a single x here, notice that it's a common factor. So I'm going to factor that common x out, and that leaves me in the first term with a c plus, in the second term there's a b. And that's again still equal to c times a. So to get x by itself, I want to divide by this quantity. Now remember, I can't divide by 0, so I'll somehow have to decide if this is equal to 0, and that's where this comes in. They told us that for a reason. Since b is not equal to negative c, if I add a c to both sides, that tells me that b plus c is not equal to 0, and because addition is commutative, that also means that c plus b is not equal to 0. So I can divide by it. So dividing both sides by the quantity c plus b, on the left simply gives me x, and on the right I get the fraction ca all over the quantity c plus b. So that gives me the value for x, given that x satisfies this equation with the various unknowns in it. So we have solved that equation for the variable x.